2017 Higher Level Question 8. 8 Part A. Using notes and freehand sketches, discuss the importance of each of the following in providing adequate light on a work surface in a kitchen as shown. Natural light and artificial light. So here we're going to discuss both individually. So we'll start with natural light. So work surfaces are the primary task areas in kitchens. A light meter could help in the design of a lighting plan. It is important to design so that light is evenly provided while avoiding excess glare. Natural light aids positive mental health and a general sense of well-being. So here we have two basic diagrams giving an indication how natural light can work and its importance. For artificial light, it provides safe and effective illumination for preparing, cooking and eating. Lighting can be provided specifically for certain locations such as sinks, countertops, hobs and lighting. Sensors could be used to reduce energy that is consumed, and lights can be mounted on ceilings, walls or cabinets. Again, we have a simple diagram of how task lighting can be used. If using the work surface, there are 4 marks for the notes on natural light, 4 marks for your sketches, 4 marks for notes on artificial light, and 4 marks for the sketches. So that is a total of 16 marks for Part A. Part B. A home office as shown measures 4.8 meters long and 3.5 meters wide. The office has a vertical window and unobstructed views. An average illumination of 500 lux of daylight is required on the work plane. Determine using the degree of efficiency method or any other suitable method the approximate area of glazing required to provide the stated illumination. Assume the illumination of a standard overcast sky to be 5000 lux. So it's very important on this to know our formula and their different definitions and symbols for understanding. So the formula for degree of efficiency method is Li equals Lo by Wf by E by window area over floor area. So we have Li equals lux required, Lo equals standard overcast sky, so we're given that in the question, so we're assuming it's 5000 lux. Wf equals window factor, which is the reduction of incident light due to window position. On a vertical wall, it has a constant value of 0.5. E equals efficiency coefficient, reduction for reflections, obstructions, glass, etc. And this is a constant value of 0.4. So we use these to input our figures into the data. So Li equals 500, then we have equals 5000 by 0.5, which is Wf, window factor, by 0.4 E, which is efficiency coefficient, by window area over floor area, and our floor area is 4.8 by 3.5. So then our next line, 500 equals 5000 by 0.5 by 0.4 by window area over 16.8 when we multiply 4.8 and 3.5. Our next line, 500 equals 1000 by window area over 16.8 Underneath that, when we gather this data, it's 500 equals 1000 WA over 16 point A. We can bring the 16.8 across to multiply by the 500, and we get 8400 equals 1000 WA. If we just swap the sides of both of them, then we just want to get the WA on the left hand side, and then we bring the 1000 underneath the 8400 for the window area, and we're getting 8.4 meters squared. There are 20 marks going for part B. You get 3 marks for the formula and 3 other marks for working your way down through it, and then 2 for getting the correct answer for the window area. That's a total of 20 marks. Part C. Using notes and freehand sketches, discuss 3 advances in glazing technology that make modern glazing systems more energy efficient. So 3 advances in glazing technology that make modern glazing systems more energy efficient are insulated glazing units, low emissivity glazing, so low E glazing, and dynamic/smart glass. So you can see the explanation for each along the left hand side, and then it asks for sketches as well, so you're given a sketch on the right hand side to explain it fully. Part 1. Insulated glazing units. Double or triple glazed units sealed to form a single unit. Cavity filled with argon or krypton gas, giving a much lower E value. Aerogel technology is being developed which allows even greater insulating properties. So in the diagram then you have the sealed cavity and light entering. Two, low E glazing. Microscopically thin metallic layer is placed on the inside surface of the glass plane. Low E coating allows the sun's shortwave radiation to pass through to the inside. Re-radiated heat from inside the dwelling in long wave form is reflected back into the room. So we can see the short waves passing through and the long waves reflected. 3. Dynamic/smart glass. This enables glass to change tint when necessary to reduce glare and heat load. It provides a greater level of comfort for the occupant, and it's electrochromic. Metallic oxide layers are fixed to the surface of the glass. So you're getting 4 marks for your notes on your first one and 4 marks for your sketches, and the same on your second and third. So that's a total of 24 marks for part C. So it's 24 marks for part C, 20 marks for part B, and 16 marks for part A.